Hi, I'm Patrick Reagan. Welcome to the Windows Tools Part 14 Certificate Manager. During this video, we will introduce digital certificates and how to manage them on your Windows computer. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Encryption is the process of scrambling or encoding data into an unreadable format or ciphertext to prevent unauthorized access, ensuring only authorized users with a specific key can read it. Asymmetric encryption, also known as public key cryptography, uses a pair of keys consisting of a public key and private key to secure data communications. Public and private key pairs are generated using complex randomized mathematical algorithms like RSA or ECC. Private key is created first, and the public key is deterministically computed from it. The private key is kept secret. The public key is embedded in a digital certificate signed by a certificate authority to verify identity and enable secure encrypted communications, and is widely distributed and is typically used for encryption. Data encrypted with the recipient's public key can only be decrypted with the corresponding private key and vice versa. Key usage includes encrypt for someone. Others use the public key to encrypt data, and only the secret private key can decrypt it. And for digital signatures, you can use a private key to sign documents or emails, and others use your public key to verify you sent it. A digital certificate, also known as the Public Key Certificate or SSL/TLS certificate, is a digital document that is used to verify the authenticity of an entity, such as a website, server, or individual, and to facilitate secure communications over the internet. Digital certificates are issued by trusted third-party organizations known as certificate authorities or CAs and serve as a form of digital identification and authentication. A digital certificate can be used as a form of authentication based on what you have authentication. The key components and characteristics of a digital certificate include entity information, the public key, digital signature, validity period, and certificate authority or CA information. Digital certificates are often used with SSL or TLS encryption, email security, code signing, and document signing. When you visit a website, you get the public key from the website's digital certificate, and you'll encrypt the initial message sent to the website with the public key. The server has the private key and is the only one that can decrypt it and read it. Much like your driver's license or ID, digital certificates have valid dates that the certificate is valid, and the names that it is validating, and who signed and can validate that the digital certificate is legitimate. The chain of trust is a hierarchy order list of digital certificates that verifies the authenticity of the entity, such as a website or software. It links an end-user certificate back to a trusted root certificate authority. It ensures that trust is passed down from a trusted source, allowing the operating system to verify certificates. Three key components include the root certificate or trust anchor, which is the most trusted top-level certificate, typically pre-installed in the Windows Trusted Root Certificate Authority store. Intermediate certificate acts as the intermediary or bridge between the root and the end entity, providing security and flexibility. An entity certificate, or the leaf, is a certificate issued to a specific entity, such as a website like google.com or a software file. A self-signed certificate is an SSL/TLS certificate issued and signed by an entity using it, such as the server, rather than a trusted certificate authority. While they provide encryption for data in transit and are free, they lack third-party validation, causing browsers to display warning messages. They're ideal for internal testing, development environments, and secure private non-public communications. Digital certificates managed via certmgr.msc for the current user and certlm.msc for local machines or electronic credentials used to verify entities, enable encryption, and ensure integrity for services, users, and computers. They secure network connections such as SSL and TLS, sign code, and enable encrypted email or smart card logins. certlm.msc was used for local machine manage certificates that apply to the entire computer, such as the machine authentication, web server IIS SSL certificates, and root trust certificates for all users. It requires administrator access. certmgr.msc is for the current user that manages the certificates specific to the logged-in user, such as personal email encryption, such as SMIME, client authentication certificates, and personal code signing certificates. Key uses of these certificates include authentication, which verifies the entity of users, computers, or devices on the network; encryption, which secures data transmissions and protecting confidential data; digital signatures, which ensure software or documents have not been tampered with and verifying their origin; and smart card login, which allows secure access to Windows using hardware tokens. The Trusted Root Certification Authorities node is the central certificate store containing root certificates from certificate authorities or CAs that Windows explicitly trusts. Certificates here, such as Microsoft Root Authority or VeriSign, form the top of the chain for SSL or TLS, code signing, and VPN authentication. Any certificate placed in this folder is deemed trustworthy by the Windows operating system for verifying entities. These certificates are pre-installed by Microsoft, updated via Windows Update, or added by administrators for internal private key infrastructure, or PKI. The personal node is the primary certificate store for holding entity certificates that include their corresponding private keys. It houses certificates specifically assigned to a user or machine, such as those used for SSL or TLS, code signing, or EFS. The system holds both the private key and public key. The public key will be stored in the digital certificate stored in the personal node, and the private key is stored securely in the system registry or trusted platform module, or TPM. Applications like Microsoft Internet Information Services or IIS Web Server or Microsoft Edge look in this store to locate certificates for secure communications. To view a certificate, you must go to the correct node and double-click the specific certificate. Common nodes include personal certificates for machine or usage-specific certificates. Trusted Root Certification Authority certificates is for root certificates. And Intermediate Certificate Authority certificates for intermediate certificates. The General tab will show you who or what certificates are issued to and by, the valid dates, if you have a private key or not, and if the CA root certificate is trusted. Search from certlm.msc. Details tab shows the following. The subject, or CN, displays the fully qualified domain name or host name of the machine, which is crucial for ensuring the certificate matches the server's entity. Subject alternative name, or SAN, lists all the domain names or IP addresses the certificate covers. This is critical for web servers and modern browser trusts. Issuer identifies the certificate authority, or CA, that signs the certificate. Valid from and to defines the exact dates for which certificate is valid, which is essential for monitoring expiration. The thumbprint is a 40-character SSH1 hash that uniquely identifies the certificate. The signature algorithm shows the cryptographic algorithm and hash function. Public key lists the key size, such as RSA 2048-bit or 4096-bit. To install a digital certificate, such as .crt, .cer, or .pfx, double-click the certificate and run through the wizard to place it in the correct store and node. If double-click only opens the digital certificate, instead of installing it, click the Install Certificate button. To export the digital certificate, right-click the desired certificate, click All Tasks, Export, and click Next. If you have a private key and the private key is exportable and you want to export the public and private key, click Yes, Export the Private Key option, and click Next. If not, click No, Do not export the private key, and click Next. Choose one of the following formats and click Next. Personal Information Exchange, or PKCS number 12, is used to export certificate along with the private key and all certificates in the certification path. It requires a password to secure the private key. This is commonly used for moving certificates between Windows servers. Cryptographic Message Syntax Standard, or PKCS number 7, certificates is used to export certificates and all intermediate certificates, but cannot include the private key. It is highly compatible with other platforms like Java. dir encoded binary x.509 is a binary format that exports only the public certificate. Base64 encoded x509 is an ASCII text format that exports only the public certificate, which is commonly used for Unix-based systems. And Microsoft Serialized Certificate Store is a format that can contain one or more certificates, usually exporting via PowerShell, but often related to certificate store management. Then specify a file name and location and click Next. Click Finish. To delete a certificate, just right-click the certificate and click Delete. Question: which tool is used to view the digital certificate used by an individual user? Answer: certmgr.msc. Question: which tool is used to view the digital certificate used by a computer running Windows? Answer: certlm.msc. Question: you're experiencing issues connected from a laptop to the corporate network using PKI. Which of the following tools can be used to help remediate the issue? Answer: certmgr.msc. Question: which type of key would you find on a digital certificate? Answer: public key. For more information, visit the following sites shown on the screen. In summary, asymmetric encryption, also known as the public key cryptography, uses a pair of keys consisting of a public key and a private key to secure data communications. The public key is embedded in a digital certificate signed by a certificate authority to verify entity and enable secure encrypted communications, and is widely distributed and is typically used for encryption. Data encrypted with the recipient's public key can only be decrypted with the corresponding private key, and vice versa. A digital certificate, also known as the Public Key Certificate or SSL/TLS certificate, is a digital document that's used to verify the authenticity of the identity, such as the website, server, or individual, and to facilitate secure communications over the internet. The chain of trust is a hierarchy-ordered list of digital certificates that verifies the authenticity of an entity, such as the website or software. certlm.msc, which is used with local machine, managed certificates that apply to the entire computer, such as machine authentication, web server SSL certificates, and root trust certificates for all users. certmgr.msc, which is used for current user, managed certificates specific to the logged in user, such as personal email encryption, client authentication certificates, and personal code signing certificates. Thank you for watching this video. The next video will be Windows Tools Part 15, the Registry and regedit. If you like this video, click the like button. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.